Figuring Out Geometry, Math Busters. Alright, here we go. By Rebecca Wingard-Nelson. Here we go. Contents. We're going to skip the introduction. And let's go to the first chapter. Points, lines, and planes. Some geometric terms are words you use every day, but they have special meanings in geometry. Points. In geometry, a point is an exact location in space. The symbol for a point is a dot. A point is usually named using a capital letter, like A, Q, and X. A point can be written as A, like that, or point A. Using points. Points are used to name an exact location. The blue dot is at point A. The lines cross at Z, and then the point, so point Z. Okay? Lines. In geometry, a line is a straight set of points that extends in two directions and does not end. Arrows are used to show that a figure is aligned. Okay? The symbol for a line has arrows on each end. Lines can be named by 2 points on the line, AB, and then that symbol, or line AB. Lines can also be given a single letter name, like line D. Horizontal, vertical, and oblique. Okay, so line EF is called a horizontal line. It appears to go straight, left, and right. So that's a horizontal line. Line GH is called a vertical line because it's up and down. Okay, it appears to go straight, up, and down. Line K is called an oblique line. It is not horizontal or vertical. There we go. Okay. Planes. A plane is a flat surface that continues in all directions. You can think of a plane as a blackboard, a tabletop, or a floor that goes on in all directions forever. Naming a plane. Planes are named using any 3 points that lie on the plane. The plane below can be named plane LMN, MNL, LNM, or any other combination of the 3 points. Alright. Chapter 2, Rays and Line Segments. Sometimes you only have part of a line. Part of a line is called either a ray or a line segment. Rays. A ray is part of a line that starts at a point and extends forever in one direction. The symbol for a ray has an arrow on just one end, which is different from the line, which had the 2. So just one arrow. The point where the ray starts is called its endpoint. So where the ray starts is called the endpoint. Interesting. Naming rays. Name 2 rays in the figure below. Okay. Step 1. The ray shown in red begins at point L and extends through point N. A ray is named using the endpoint first, then any other point on the ray. The ray shown in red is named LN. Okay? The endpoint first. Okay, step 2. A ray can be part of a whole line in a figure. Use a point on the line as an endpoint. Use another point on the line to show in which direction the ray extends. You can use point L to name a ray that is part of KM. Okay, so the line KM. Okay, so LM would be the ray shown in blue as LM. 2 rays in the figure are LN and LM. Alright? Line segments. A segment or line segment is part of a line. It has 2 endpoints. A line segment is named using its endpoints. The symbol for a segment has no arrows, so line segments have no arrows. Okay, naming line segments. Name 2 line segments in the figure. Okay, can you do it? Step 1. Line segments are named using 2 endpoints in any order. The line segment shown in red has endpoints at point A and point B. The line segment shown in red can be named AB or BA. Okay, so AB or BA. Okay. A line segment can be part of a whole line or part of a ray in a figure. The line segment in blue is part BC. Okay? It can also be named CB, so BC or CB. Alright. 2 line segments in the figure are AB and BC. Okay? Manta rays and stingrays look like geometric rays. They have a straight tail and a body that is shaped like an arrow. A segment on a worm is just one section or piece of the worm, just like a line segment is a piece of a line. Okay. Next chapter, line relationships. When two or more lines are in a figure, there are special terms that tell how the lines are related. Intersecting and perpendicular lines. Lines, rays, and line segments that meet are called intersecting. Okay, so that's the point of intersection. Alright? Line AB and line LN are intersecting lines. Okay, so AB and LN are intersecting lines. Segment AB and segment LN are intersecting segments. The point where the lines or segments meet, point M, is called the point of intersection. Perpendicular lines are intersecting lines that form four right angles. Right angles measure exactly 90 degrees. Okay, so that symbol tells you the angle measures 90 degrees. The symbol, this little symbol that kind of looks like an upside down T, means is perpendicular to. Line GH and line JK are perpendicular. Okay? Because you can write this as GH perpendicular upside down T to JK. Okay? Parallel lines. Parallel lines are in the same plane and never cross because they are always the same distance apart. Segments and rays of parallel lines are also parallel. The symbol, like two L's or two little L's would be, is parallel to. Line EC and line FD are parallel. You can write this as relating lines. Name a line that is parallel to AB and a line that is perpendicular to AB. Step 1. Find a line that will never cross AB. Okay? LM will never cross AB. So LM will never cross. So they are parallel. Alright. Find a line that forms right angles with AB. DF forms right angles with AB. Okay, so DF and AB, that means they are perpendicular. Lines that line the same plane either intersect or are parallel. Lines that line different planes may intersect, be parallel, or do neither. Lines that are in different planes and do not intersect are called skew. Skewed lines, okay? Alright. Chapter 4, angles. Angles are formed where lines, rays, or line segments intersect. Alright. Angles. An angle is formed by two rays that share an endpoint. This shared endpoint is called the vertex. Okay? The vertex. You can name an angle in three ways using the angle symbol. Use the vertex. The angle above is vertex C. Okay? So, angle symbol C. Use three letters in this order. A point on one ray, the vertex, and a point on the other ray. Okay? This is angle ACB or BCA. Use a number that is inside the angle. This is 1. Alright? Okay. Naming angles. Use two ways to name the angle formed by MN and MB. Step 1. Name the angle using the number inside the angle. Okay? So we're going to go with 3. Okay, right here. MN, MB, 3. Name the angle using a point on one ray, the vertex M, then a point on the other ray. Okay, so we can do NMB, MB, or we can do it this way, BMN. Okay? And that's the symbol we use. You cannot use the name M for this angle. There are 4 angles that have a vertex at point M. See? So there's a lot of choices, so we'd have to be more specific. Angle measurement. The measure of an angle tells how far one ray is turned from the other. Angles are measured in units called degrees. The symbol means degrees. 90 degrees is read 90 degrees. No turn at all is 0 degrees. A quarter turn is 90 degrees. A half turn is 180. A full turn or a complete circle is 360 degrees. Classified angles. Angles are classified by how they relate to 90 degrees and 180 degrees. Okay, so angle 1. Acute angles measure less than 90 degrees. Measure 1 is acute. Right angle is exactly 90, and that little box will give it away. And that's how you'll know it's a right angle. Okay? And then 3 obtuse angles measure greater than 90 degrees and less than 180. So, less than 180, more than 90. Straight is exactly 180. So a straight line is exactly 180. So the angle for straight angle. Reflex angles measure greater than 180 and less than 360. Okay, so that's a reflex. Okay. Angle relationship. Some angles are related by their positions or their measurements. These related angles have special names. Related angles. Adjacent angles. Angles that share a vertex and a side. 1 and 2 are adjacent angles. They share vertex A and side AB. Congruent angles. Angles that have the same measure. The word congruent means the same as or equal. The symbol for congruent is equal sign and little squiggly. Complementary angles. Two angles whose measure add up to 90 degrees. Supplementary angles. Two angles whose measures add up to 180 degrees. Okay, congruent angles. Which angle is congruent to HKM? Okay. Okay. So remember, congruent angles. Angles that have the same measure. Step 1. Find the measure of HKM. HKM measures 48. Tells you right there. Step 2. Find another angle that measures 48. The measure of 2 is 48. So HKM and angle 2 have the same angle measure, so they are congruent. That's our little symbol for congruent, meaning the same or equal, right? All right. Angle sums. Which two angles have complementary? Which two angles are complementary? Step 1. The angle sum of complementary angles is 90 degrees. To find the angle sum, add the measures of two angles, which two angles measures add up to 90 degrees. The measure of angle 1 is 30. The measure of angle 4 is 60. So 60 plus 30, 90. So they're complementary. Okay, so we 30 plus 60 equals 90. When complementary angles are adjacent, they form a right angle. Okay, then we can put the little box. Which two angles are supplementary? The angle sum of supplementary angles is 180. Which two angle measures add up to 180 degrees? So 45 plus 135 equals 180. The measure of angle 2 is 45. The measure of angle 3 is 135. 2 and 3 are supplementary. When supplementary angles are adjacent, they form a straight angle. Okay. So, chapter 6, angles of intersecting lines. When two lines intersect, they form four angles. The four angles are related in special ways. Intersecting lines. The four angles formed by two intersecting lines go all the way around the point of intersection. The sum of the measures of the four angles is 360. Alright, point of intersection. Linear pair. Two adjacent angles that are formed when two lines intersect. Linear pairs always form a straight line, so they are supplementary, add up to 180. For the figure above, the linear pairs are 1 and 2, right? 2 and 4, here we go. 3 and 4, or 1 and 3. Okay? Vertical angles. Two angles that are not next to each other when two lines intersect. Vertical angles always have the same measurement, so they are congruent. For the figure above, the vertical angles are 1 and 4, and then 2 and 3. Linear pairs. What is the measure of angle 2? Okay? Decide what you know from the figure. 1 and 2 are a linear pair. The measure of angle 1 is 65. So, step 2, linear pairs are supplementary angles. The angle sum of supplementary angles is 180. Measure of angle 1 plus measure of angle 2 equals 180. Write in the angle measures that you know. 65 degrees plus measure of 2 equals 180. Subtract 65 from 180 to find the measure. Bam. 115. Vertical angles. What is the measure of side 3? Decide what you know from the figure. You know 1 and 3 are vertical angles. The measure of angle 1 is 65 degrees. Vertical angles are congruent. Congruent angles have the same measure. 1 and 3, angles 1 and 3 have the same measure. So 1 measures 65, so 3, 65. The measure of 3 is 65. Chapter 7, plane figures. Plane figures are flat, like a shadow on a piece of paper. They are called plane figures because they lie on one plane. Plane figures. A side is a curve or line segment that is part of a plane figure. A vertex is a point where line segments or curves of a figure meet. Vertices is a plural for vertex. A closed figure is a plane figure that begins and ends at the same point. An open figure does not begin and end at the same point. So that's the side. Those are the vertices. That's another side. Closed figure. Open figure, right? A polygon is a special kind of plane figure. Polygons are closed plane figures with sides that are all line segments. So, not a polygon, not a polygon, not a polygon, polygon. Okay? Regular polygons. Regular polygons have sides that are all the same length and angles that all have the same measure. Okay? Regular. Okay? Not regular. Regular. Not regular. Polygons. Polygons are classified by the number of sides or angles they have. Some common polygons are in the following table. Triangle. 3 sides, 3 angles. Bang. Quadrilateral. 4 sides, 4 angles. Bam. Pentagon. 5 sides, 5 angles. Bang. Hexagon. 6 sides, 6 angles. Bang. Octagon. 8 sides, 8 angles. Bang. Nonagon. 9 sides, 9 angles. Bang. Decagon. 10 sides, 10 angles. Bang. Dodectagon. 12 sides, 12 angles. Bang. Dodecagon. That's a cool name. Name the shape of the following road signs. Step 1. All of the sides are line segments that are the same length. So this is a regular polygon. Count the number of sides. 8. What polygon has 8 sides? This sign is a regular octagon. 2, 3, 4, 5, 6, 7, 8. Okay? Step 1. All of the sides are line segments, but they are not all the same length. This is a polygon, but not a regular polygon. Count the number of sides. 1, 2, 3, 4, 5. 5. What polygon has 5 sides? This is a pentagon. Okay, triangles, chapter 8. The prefix tri means 3, so the word triangle means 3 angles. Triangles also have 3 sides and 3 vertices. Naming a triangle. Triangles are named by listing the vertices of the angles in any order. The symbol for triangle is a little triangle. This triangle can be named triangle FGH, triangle GHF, you get it, HFG, HGF, GFH, or FHG. The angles of a triangle always have a sum of 180 degrees. If you tear off the corners of any triangle and put their vertices together, the angles form a straight line. You see that? Triangle classes. Triangles can be classified by the measure of their angles. The angles in a triangle can be acute, right, or obtuse. Triangles can also be classified by the length of their sides. The sides can be all different, 2 congruent, or all congruent. A triangle with congruent sides also has congruent angles. Small lines or hatch marks are used to show that sides or angles are congruent. Remember, congruent means equal. Triangles classified by angle measure. Acute triangle, 3 acute angles. Right triangle, 1 right angle, 2 acute angles. Obtuse, 1 obtuse angle, 2 acute angles. Triangles classified by side length. Scalene, no equal sides. Isosceles, 2 equal sides. Equilateral, 3 equal sides. Okay? Classify ABC by angle measure and by side length. Classify ABC by the measure of its angles. There is 1 right angle, the other 2 are acute angles. So, ABC is a right triangle. Remember, acute, less than 90, right, equal 90, obtuse, greater than 90. Classify ABC by the length of its sides. 2 sides have the same length. They are congruent. ABC is an isosceles triangle. 3. Combine the terms to classify the triangle by both angle measure and side length. It's an isosceles right triangle, okay? Chapter 9, Quadrilaterals. Quad means 4. Lateral refers to side. Quadrilaterals are polygons with 4 sides. Quadrilateral classes. Quadrilaterals are classified by how their sides are related. A kite has 2 distinct pairs of adjacent, next to each other sides that are congruent. Okay? Trapezoid has only 1 pair of parallel sides. Okay? A parallelogram has 2 pairs of parallel sides. The parallel sides are congruent. Okay, you see? A rhombus is a parallelogram with 4 congruent sides. Okay? A rectangle is a parallelogram with 4 right angles. A square is a rectangle with 4 congruent sides. Overlapping classes. Some quadrilaterals will fall into more than one class. Look at the figure and decide how many ways it can be classified. Step 1. Start at the top of the classifications on page 22. Is this figure a kite? No. There are no adjacent sides that are congruent. Is this figure a trapezoid? No. It has more than 1 pair of parallel sides. Is the figure a parallelogram? Yes. There are 2 pairs of parallel sides. Is this figure a rhombus? No. It does not have 4 congruent sides. Is this figure a rectangle? Yes, it is a parallelogram with 4 right angles. 6. Is this figure a square? No, all 4 sides are not congruent. This figure is both a parallelogram and a rectangle. Angle sums. The sum of the angles of a quadrilateral is always 360. What is the measure of a missing angle? The corner symbol in the figure means those angles are right angles, or 90-degree angles. You know the measures of 3 of the angles, and add the angle measures that you know. 90, 90, 90, 50 equals 230. Step 2. You know the angle sum of all 4 angles must be 360. You know the angle sum of the 3 angles is 230. Subtract to find the remaining angle measure. 360 minus 230 equals 130. The missing angle measure is 130. Okay. 10. Circles. Circles are not polygons. They have no line segments. Circles are formed by one closed curve. Circle term. Center. A circle is a curved set of points that are all the same distance from a given point. That point is a center. A radius. A line segment that has one endpoint on the circle and the other on the center of the circle. The plural radius is radii. So radius, center. Okay? Chord. A line segment that has each endpoint on the circle. Okay? Diameter. A chord that passes through the center of a circle. The diameter of a circle is always twice the radius. Okay? Central angle. An angle formed by 2 radii. The vertex of a central angle is the center of the circle. Vertex. Central angle. Measurements. Suppose this key ring is a circle with a radius of 15 millimeters. What is the diameter of the key ring? Step 1. Diameter is twice the radius. Multiply the radius of the key ring by 2. 15 millimeter times 2. 30 millimeter. The diameter of the key ring is 30 millimeter. Semicircles and arcs. A semicircle is half a circle and includes the diameter. Semicircles are named using the 2 endpoints of the diameter and one other endpoint on the half circle. Semicircle ACB can also be called semicircle ABC, BAC, BCA, CAB, or CBA. Semicircle ACB. An arc is part of the curve of a circle. A major arc is equal to or greater than a semicircle. Major arcs are named by 3 points that include the endpoints. A minor arc is less than a semicircle. Minor arcs are named by their 2 endpoints. Okay? Major arc, y, x, z. Minor arc, z, y. What kind of arc is the letter C? Look at the letter C. Is it equal to or greater than a semicircle? Yes. The letter C is a major arc. 11. Prisms. In geometry, the word solid has a different meaning than you might usually use. Solid figures are ones that are not flat. Solid figure. Solid figure. A geometric figure that has 3 dimensions. Length, width, and height. 2 dimensions. Not a solid. 3 dimensions. Solid. Okay? Length, width, and height. Solid, baby. A solid figure with all flat surfaces. Each flat surface is a polygon. There are no curved surfaces. Not a polyhedron. A polyhedron. Okay? Face. A flat surface of a solid figure. Base. The face of a solid figure that names the figure. Some solids have 2 bases. Edge. The line segment on a solid figure where 2 faces meet. Vertex. A corner point of a solid figure. Vertex. Base. Face. Edge. Prisms. A prism is a polyhedron that has 2 congruent parallel bases. All of the other faces are rectangles. Prisms are named by the shape of their bases. For example, a triangular prism has bases that are triangles. Triangular prism, rectangular prism, cube. A cube is a square prism, has bases that are square, with faces and bases that are all congruent. All of the edges of a cube are the same length. Prism parts. The number of faces, edges, and vertices that a prism has is determined by the shape of the bases. The table below lists a few. Faces equal base sides plus 2. Triangle 5, pentagon 7, 10. Edges, base sides times 3, 9, 15, 24. Vertices equal base times 2, 6, 10, 16. How many edges are there on a hexagonal prism? The base of a hexagonal prism is a hexagon. How many sides does the hexagon have? 6. Multiply the number of sides by 3. So 6 times 3, 18. Edges times 3. A hexagonal prism has 18 edges. 12. Pyramids. Pyramids have been used in architecture since ancient times. Their shape is used to form tombs, temples, monuments, and even modern museums. Pyramids. A pyramid has one base. There's a triangular face for each base side. Their faces meet at a common point. Pyramids are named by the shape of their base. For example, a rectangular pyramid has a base that is a rectangle. Base. Apex. Lateral face. A lateral face, a triangular face of a pyramid. Apex, the vertex where all the triangular faces meet. Naming the parts. Classify the pyramid and name the vertices, edges, and faces. Step 1. Classify the pyramid by the shape of its base. How many sides does the base have? 5. What polygon has 5 sides? A pentagon has 5 sides. This is a pentagonal pyramid. Step 2. Name the vertices. The vertices are the corner points. Okay? So, vertices of a pyramid include the apex and the points where the base meets two faces. The apex is point F. Other vertices are points A, B, C, D, and E. The vertices are point A, B, C, D, E, and F. Name the edges. Edges are the line segments where two faces meet. The edges are AB, BC, CD, DE, AE, AF, BF, CF, DF, and EF. Step 4. Name the faces. The base and lateral faces are all the faces of a pyramid. Name each of the faces by listing the polygon's vertices in order. The faces are pentagon are A, B, C, D, E. ABF, BCF, CDF, DEF, and triangle EAF. Okay? Pyramid parts. Like a prism, the number of faces, edges, and vertices a pyramid has is determined by the shape of the base. Base shape, triangle. So we take the faces equals base, sides, plus 1. So 4 for quadrilateral is 5, right? So 3 plus 1, 4 plus 1, 5 plus 1, 6 plus 1. For octagon, 8 plus 1, nonagon, 9 plus 1, okay? And then the edges, we do base sides times 2. So then we take 3 times 2 is 6, etc., etc. So just multiply it by 2. Okay? For quadrilateral, pentagon, hexagon, octagon, nonagon. And then for the vertices for the pyramid, we take the base sides plus 1. So 4. So kind of the same idea we have for faces and vertices. It's the same formula, okay? Which is why we have the same answers. Okay. Chapter 13, Cones and Cylinders. Cones and cylinders are different types of solid figures. They do not have polygons for bases. Cones, the base of a cone, is one closed curve. Most cones have a base that is a circle. A cone has an apex, a base, and one lateral face. There's the apex, the lateral face, and then the base. The height of a cone is the line segment that connects the apex of the cone to the base at a right angle. So there's a right angle, the height. When the base is a circle and the height is at the center of the circle, the cone is called a right circular cone. Cones are found all over the world. There are traffic cones, ice cream cones, cone-shaped hats, and volcanoes and mountains that are cone-shaped. Cylinders. A cylinder is a solid with two parallel bases that are congruent, closed curves. Cans are usually shaped like cylinders, so are paper towel rolls and most water pipes. The height of a cylinder is a segment that connects both bases at right angles. Height, face, bases. Nets. If you cut around the bases and down the face of a solid, then flatten them, the result is called a net. In the net of a cylinder, what shape does the face of a cylinder make? Step 1. Cut around one base of a cylinder. Fold it up. Step 2. Cut around the second base of a cylinder. Fold it down. Step 3. Cut a straight line down the face of the cylinder. Unroll the face. The face of a cylinder unrolls into a rectangle. Okay. 14. Spheres. Spheres are solid figures, but they do not have any bases. Earth is a sphere. So is a ball. Spheres. A sphere has no bases. It is one smooth curved surface on which every point is the same distance from the center. The center, and then the radius. Okay? The term sphere is used to describe things that are round like balls. They can be solid or hollow. In geometry, a sphere is more like a soap bubble than a ball. You can measure from one side of the bubble to the other, but the thickness of the shell does not have a measurement. Cross sections. Imagine a plane slicing a sphere. What shape would be made at the intersection of the plane and sphere? Step 1. Picture a plane slicing a sphere. The slice can be made anywhere across the sphere. Look at the plane figure that is made where the plane intersects the sphere. What plane figure do you see? Plane figure is a circle. In a sphere, any slice is going to result in a circle. Where the slice is made determines the size of the circle. Okay. The largest possible circle will include the center point. Two-dimensional slices of solid figures are called cross sections or plane sections. 15. Line symmetry. When some figures are folded in half, the two parts will match exactly like mirror images. Symmetry. A figure has line of symmetry when one half of its mirror image of the other half. Sometimes this is called symmetry. A line of symmetry divides a figure into two matching parts. Here's the line of symmetry. Some figures have no symmetry. Others have 1, 2, or even more lines of symmetry. No symmetry. 1 line of symmetry. 5 lines of symmetry. Okay. 2 lines of symmetry. Okay, letter of symmetry. Many numbers in capital letters have 1 or more lines of symmetry. In the word math, which letters are symmetric? Step 1. Does the letter M have any lines of symmetry? Yes. You can split it in half. There you go. Step 2. Does the letter A have any lines of symmetry? Yes. Step 3. Does the letter T have any lines of symmetry? Yes. Does the letter H have any lines of symmetry? Yes. It actually has 2. Cool. Okay, yes. All the letters in math are symmetric. Polygon, symmetry. How many lines of symmetry are in a square? Step 1. You can tell if a shape has a line of symmetry by making a paper model. If you can fold the model one time into 2 matching parts, the fold line is a line of symmetry. Okay. Fold the square on the diagonals from corner to corner. The 2 parts are matching triangles. You can make two diagonal folds. Step 2. Fold from the center of one side to the center of the opposite side. The parts are matching rectangles. You can do this 2 ways. Fold top to bottom and side to side. There are 4 lines of symmetry in a square. A diagonal is a line that connects any 2 non-adjacent vertices of a polygon. 16. Congruence. If you make an exact copy of a figure, the copy and the original are congruent. Congruent figures are exactly the same shape and size. Congruent figures. Congruent line segments have the same length. Congruent angles have the same measure. Congruent figures have all the congruent sides and angles. One congruent figure will fit exactly on top of the other. A, B, C, that's a symbol for congruent too, is congruent to triangle DEF. Comparing figures. Are the given figures congruent? Step 1. One way to decide if figures are congruent is to put them on top of each other. If they line up exactly, the figures are congruent. Figures do not line up, so they are not congruent. Okay? Correspondence. When you compare figures, the sides that match each other are called corresponding sides. The angles that match each other are called corresponding angles. In congruent figures, corresponding sides and corresponding angles are also congruent. Corresponding parts. Trapezoid JKLMN and trapezoid RSTU are congruent. What is the length of side ST? Imagine the trapezoid's line on top of the other. Which sides and angles correspond? Corresponding sides. JM, RU, JK, RS, KL, ST, LM, TU. Corresponding angles. JR, KS, LT, and MU. Right? MU, LT, and then LM is the same as TU. Okay? Congruent sides have the same measure. The length of side ST is the same as the length of side KL. Side KL is 4 units long. The length of side ST is 4 units. When the problem does not tell you what the units are, use the words units rather than leave the units off. 17. Similarity. Similar figures are alike, but not always exactly the same. Similar figures. Similar figures have the same shape. They do not need to be the same size. ABC, that means is similar to DEF. An enlargement or reduction of a picture makes a similar picture. The shapes are the same, but the sizes are different. Similar figure correspondence. Similar figures, like congruent figures, have corresponding parts. The corresponding angles of similar figures are congruent. The corresponding sides of similar figures are proportional. That means the ratios of the lengths of corresponding sides are the same. Similar polygons. Are triangle JHJ and KLM similar? Are the corresponding angles congruent? Yes. J, K, H, L, J, and M. So they are congruent. Are the corresponding sides proportional? Write a ratio to compare each of the sides, each pair of corresponding sides. So length of JH is F, so F5. And then length of KL is 10, so that's 1/2. So 1/2. The corresponding sides all have the same ratio, 1 to 2. So yes, they are proportional. To check for similarity, they are similar. Okay? All right. To check for similarity, always check the ratios of the sides. Both a square and a rectangle have 4 90-degree angles, but that does not make them similar figures. That's not similar to... Okay. So, 18. Slides. Translations. When you slide a coin over a surface like a table, its shape and size stay the same. It just moves to another place. In geometry, figures can slide the same way. Translations. In geometry, a slide is also called a translation. A translation moves each point in a figure the same direction and the same distance. The original figure and its translated image are congruent, and they face the same direction. A slide arrow can be used to show the direction and the distance of a translation. Recognizing a slide. Which set of triangles shows a slide or translation, A or B? Step 1. Look at the triangles in set A. Draw a ray called a slide arrow. From each vertex to the corresponding vertex, the slide arrows are not all the same direction or length. The slide arrows show that each vertex moved differently. The triangles do not face the same way. This is not a slide. Okay, step 2. Look at the triangles in set B. Draw a slide arrow from each vertex to the corresponding vertex. The slide arrows are the same direction, parallel, and the same length. The slide arrows show that each vertex moved in the same way. Triangles face the same way. This is a slide. The triangles in set B show a slide or translation. Drawing a slide. An easy way to slide a polygon is to use a grid. Use the grid to slide this figure 3 units left and 5 units down. Step 1. From any vertex, count 3 units left and 5 units down. Okay, draw a new vertex at the new point. The new corresponding vertex takes the same letter name with a small line like an apostrophe. A is read A prime. Do this for each vertex. Step 2. Connect the new vertices. Since every vertex moved the same distance in the same direction, all of the sides did also. The new figure is a translation or slide of the original. You can also use a stencil or cutout to show a slide. Just make the figures face the same direction. Okay. 19. Flips. Okay, reflections. In symmetric figures, one half of a figure can be flipped over a line of symmetry to match the other half. When a whole figure is flipped over a separate line, it creates a reflection like a mirror. Reflections. In geometry, a reflection or flip creates a mirror image. The image has the same size and shape as the original figure, but it faces the opposite direction. Corresponding points on the figures are the same distance from the line of reflection. The line of reflection is where the mirror would be. Here we go. Recognizing a flip. Which set of figures shows a flip or reflection? Step 1. The figures in both sets are the same size and shape. In set A, the figures face the opposite direction. In set B, the figures face the same direction. So the figures in A show a reflection. Drawing a reflection. Draw a reflection of the figure. Step 1. To draw a reflection, draw a line of the reflection first. The line can be horizontal, vertical, or oblique. Let's use a vertical line of reflection. Okay? Step 2. From any vertex, draw a line segment that is perpendicular to the line of reflection. Extend the line segment the same distance on the other side of the line of reflection. Draw a new vertex. Do this for each vertex. Here we go. Okay? Step 3. Connect the new vertices to form a mirror image of the original figure. A line of reflection is like a line of symmetry. A line of symmetry splits one figure into 2 mirrored halves. A line of reflection separates 2 mirror figures. Okay. 20. Turns. Rotations. Okay? You can make a figure face a different direction by turning or rotating it. Rotations in geometry, or rotation turns a figure around a point. The point is called the turn center or point of rotation. Each point on the figure turns by the same number of degrees. The point of rotation can be on the figure or the outside. A figure can be turned clockwise or counterclockwise. A full rotation is a 360-degree turn. A full rotation turns the figure back to where it started. Watch what happens when you turn an arrow clockwise. 90, 80, 270, and 360. No turn, 90-degree turn, 180 turn, 270 turn, 360 turn. Rotational symmetry. Rotational symmetry is also called turn symmetry. Sometimes when you turn a figure, it looks the same as it did when it started, even before you make a full turn. Figures that do have this rotational symmetry. Does this figure have rotational symmetry? Step 1. To check for rotational symmetry, you can imagine turning the figure in your head. Or you can turn the book to see what the figure looks like when it is turned. Try turning the figure a quarter turn, 90 degrees. Does it match the original figure? No. Step 2. Try turning the figure a half, 180. Does it match the original figure? Yes. A half turn makes the image match the original figure. Yes, the figure does have a rotational symmetry. Moving a figure to make a new figure is called a transformation. The new figure is called an image. You can transform a figure by sliding it, translation, flipping it, reflection, turning it, rotation. Okay. Perimeter. Part of geometry is measurement. Some measurements are found by using a tool like a ruler. Some measurements are found by using measurements that you already know. Perimeter, the distance around a figure. The capital letter P is usually used to represent a perimeter. Formula, a rule that is written using symbols. Perimeter of a polygon. Find the perimeter of this figure. Step 1. To find the perimeter of any shape, you can add the lengths of the sides. Okay? So the perimeter of the figure is 116 centimeters. So we just add them up. To find the perimeter of something that has an unusual shape, you can use a string to measure the distance around it that measures the length of the string. Perimeter of regular polygons. Find the perimeter of a square with a side length of 3 inches. Step 1. A square is a regular polygon with 4 equal sides. You can write a formula for the perimeter of any regular polygon because you can multiply the number of sides by the length of one side. The formula for the perimeter of a square is the number of sides, 4, multiplied by the length of a side. So 4 times s squared. Okay, so 4 times 3. That's how we can find it. Multiply 12. The perimeter of the square is 12 inches. Perimeter of a rectangle. Okay, P equals 2 times length plus 2 times width. Has the opposite sides that are equal in length. The perimeter of rectangle is 2 times the length plus 2 times the width. Fill in the numbers you know. Okay, 5 and then 2, which the length would be 2. Width is 5. Plug it in. Okay, we get 14. Perimeter is 14 feet. 22. Area, rectangles, and square. When you decide how much carpet, wallpaper, or paint you need to cover something, you must find the measurement of the area you need to cover. Square unit. A square that is 1 unit long and 1 unit wide. A square inch is 1 inch long and 1 inch wide. You can write square units as square units or units squared. Area. The number of square units needed to cover a figure. Area of a rectangle. Aunt Millie made a quilt of squares that is 6 squares long and 4 squares wide. How many squares make up the entire quilt? How many? Well, one way, the quilt is a rectangle that is 6 squares long and 4 squares wide. Each square is 1 unit. You can find the area or total number of squares by counting. So you can count. So 6 times 4, 24. Another way, you can find the area of a rectangle by multiplying the length times the width. The formula is written as follows. L times W, A equals LW. So A equals 6 times 4, 24. You multiply 24 squares, make up the entire quilt. Okay. Area of a square. Find the area of a square with side length of 2 inches. Step 1. A square that has sides that are all the same length. You can find the area of a square by multiplying a side times a side. The formula is S times S, or area equals S squared. This means multiply the side times 2, side times side. It reads as S squared, or side squared. Fill in the numbers you know. 2 times 2, or 2 squared. Multiply 4. A square with a side length of 2 inches has an area of 4 square inches. Be careful, a square with sides that are 2 inches long does not have an area of 2 square inches. Area of composite. Find the area of this figure, okay? So step 1, this figure is a composite. It is a rectangle and a square that are combined. Find the area of the rectangle first. So we do length times width, 10 times 3, so 10 times 3, 30 square units. So next, find the area of the square. 6, 6. So S6 squared, 36, or 6 times 6, right? Add the areas, so 30 plus 36 equals 66. 66 square units is the area of these two figures. So that's the area of a composite. 23. Area of parallelograms. You can use what you know about the area of rectangles to find areas of parallelograms. Parallelogram pieces. If you cut a parallelogram perpendicular to a side, you can rearrange the pieces to form a rectangle. So that's base, height. The base of a parallelogram can be either of the sides that correspond to the length of a rectangle. The height of a parallelogram is the length of a perpendicular line from the base to its opposite side. The height corresponds to the width of a rectangle. The formula for the area of a parallelogram is similar to the formula for rectangles. Area of a rectangle, area equals length times width. Area of a parallelogram, area equals base times height. Okay? Area of a parallelogram. Brennan is using tiles that are parallelograms to make a border design for his kitchen. Each tile has a base length of 2 inches and a height of 1.5 inches. How much area will one tile cover? Step 1. Write the formula for the area of a parallelogram. Step 2. Fill in the numbers you know. Step 3. Multiply. One tile will cover 3 square inches. So area equals base times height. Area equals 2 inches times 1.5 inches. Area equals 3 inches squared. Remember, area is always in square units. How many tiles will Brennan need to cover 360 square inches? Step 1. Decide how to solve the problem. To find the number of tiles Brennan needs, you can divide the total area he needs to cover by the area of one tile. Total area divided by area of one tile equals number of tiles needed. Step 2. Fill in the numbers you know. From the problem above, you know that each tile covers 3 square inches. 360 divided by 3, numbers of tiles needed. Step 3. Divide. 360 divided by 3, 120. He needs 120 tiles. Okay. 24. Area, triangles. You can use what you know about the area of a parallelogram to find the area of a triangle. Triangles and parallelograms. Height times base. Well, no. Okay. We'll get there. Hold on. let's do this, okay? So, let's read all this first. The base of a triangle can be any one of the sides. The height of a triangle is the length of the perpendicular line from the base to the vertex across from it. You can take any triangle, make an exact copy of it, and form a parallelogram. The base and height of the parallelogram are the same as the base and height of the original triangle. So the area of one triangle is half the area of the parallelogram. Area of a parallelogram, area equals base times height, area BH. Okay? Area of a triangle, area equals 1/2 base times height, area equals 1/2 base times height for area of a triangle. Okay? So, area of a triangle. Ben is making a flag of Guyana, a country in South America. For a social studies project, the base of the red triangle is 12 inches, the height is 9 inches. What is the area? Okay, so what is the formula? Area equals 1/2 times base times height. Fill in the numbers, 12 times 9. Okay, so then you put in 108 times 1/2 equals 54. So the area of the red triangle, right here, see it? Equals 54. Using a grid. Use a grid to count the number of units that are covered by the triangle. Then use the formula for the area of the triangle. Compare the two answers. Count the square units the triangle covers. There are 10 whole units. There are 5 half units, so 2.5 whole units. Whole units, area equals whole units plus half units. 10 plus 2.5 equals 12.5. So 1, 2, 3, 4, and then these are the halves right here. 1, 2, 3, 2, so 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12.5. Okay. Use the formula. This is a right triangle. So for the base and height, use the two sides adjacent to the right angle. The base is 5 units and the height is 5 units. Get the same answer. Compare the answers. They're the same. Okay. 25. Circle measurements. Circle measurements are a little different than polygon measurements. A special ratio called pi is used to calculate their measurements. Okay? Pi and circle formula. Circles have their own name for perimeter, circumference. The circumference of a circle is the distance around it. And in ancient times, it was found that the ratio of the circumference of any circle to the diameter of that circle is always the same. That ratio is represented by the Greek letter pi. So, circumference divided by diameter equals pi. Pi is an infinite decimal. That means it keeps going and going and going on and on without ever ending or ever repeating a pattern. It is also an irrational number. That means it cannot be written as a fraction. In geometry, an approximate number is usually used for pi. So 3.14 or pi equals 22 over 7. This sign is approximately equal to. Approximately. Okay? The formula for circumference is circumference equals pi times diameter, or circumference equals pi diameter, like written like that, without the multiplication sign. Circumference, diameter. Okay? Formula for the area of a circle, pi times radius, or radius squared. Okay? Circumference. A swimming pool has a diameter of 28 feet. A string of decorations runs around the edge of the pool. How long is a string of decorations? Okay? So, the distance around a circle is a circumference. Write the formula. Circumference equals pi times diameter. Fill in the numbers you know. Okay? String of decorations is 88 feet long. So, use the value for pi that makes the problem easiest to solve. Remember, when you use an approximation for pi, use the squiggly equal sign. Area. A solar blanket can be used to warm the water in a pool. The blanket covers the surface of the water. What is the surface area of a pool with a 24-foot diameter? Write the formula for the area of a circle. Area equals pi radius squared. Fill in the numbers you know. The problem tells you the diameter, but the formula uses radius. The radius is half the diameter. Half of 24 is 12. So, solve. The area then needs covering is about 452.16. So, that's how we do it. And that's our answer. Okay. Surface, area, and nets. When you cover a box in wrapping paper, the area that is covered is called the surface area. The surface area of a solid is the sum of the areas of all faces. Surface area of a prism. Find the surface area of this rectangular prism. Find the area of each face. The bases of this prism are rectangles. The formula for the area of a rectangle is area equals length times width. So 3 times 2 is 6. The faces of prisms are rectangles. Find the area of the rectangles that appear to be at the bottom and the top. Okay? 4 times 3, 12. Find the area of the rectangles that appear to be on the front and back. 4 times 2. Then we add them all up, and that equals 52. Surface area of the prism is 52. Okay, so then we have nets. A net is a shape that can be folded into a solid. Use the net of a solid to help you find the surface area. Using nets. Use a net to find the surface area of this cube. Make a net of the cube. You can see that the cube is made from all 6 squares that are the same size. Find the area of one square, the formula for the area. Then we get 4. Since each face has the same area, multiply the area of one face by 6 to find the surface area. 24. There can be more than one net for the same solid. Compare the net in this problem to the one at the top of the page. Both nets can be folded into a cube. Volume prisms. A three-dimensional object takes up a certain amount of space. That space is called its volume. Definitions. Volume. The amount of space a solid figure occupies. Volume is measured in cubic units. Cubic unit. A measure of volume that is 1 unit long, 1 unit wide, and 1 unit high. A cubic inch is 1 inch long, 1 inch wide, and 1 inch high. It can be written as 1 inch cubed. Okay? So find the volume of the rectangular prism. Step 1. How many cubes are in one layer of the prism? The top layer is 3 units long and 2 units wide. So the area of the top layer is 3 times 2, 6. There's 6 cubes in one layer. Step 2. There are 2 layers of cubes. So each layer has 6 cubes in it, multiplied by 2. 12. 12 cubic units. The volume of a rectangular prism is the area of the base, length times width, multiplied by the height of the prism. Remember, volume is always measured in cubic units. Formula. The formula for the volume of the rectangular prism is volume equals length times width times height, or V equals LWH. The formula for the volume of any prism is volume prism equals area of base times height. Volume equals BH. In geometric formulas, a small b is used for the length of a side, like the base of a triangle. A capital B is used for the area of the base, like the base of a prism. Find the volume of the triangular prism. Triangular base equals 5, triangular height equals 8, prism height equals 6. So step 1, the base of the prism is a triangle. Find the area of the base using the area formula for triangles. Use big B instead of A to show you are finding the area of the base. So here we do, there's the formula. Okay, the area of the base is 20 square units. Step 2, use the volume formula for any prism. Here's this formula answer. So it's the volume of the prism is 120 cubic units. The volume of a cube is easy to find. The length, width, and the height are the same, so multiply the same number 3 times. Okay, so now we have a volume of cylinders and cones. A cylinder has 2 congruent bases on opposite sides like a prism. A cone tapers from the base to a single point on the opposite side. Cylinders. The volume formulas for cylinder and the prism are the same. Volume, prism, or cylinder, area of base times height, V equals BH. The base of a cylinder is usually a circle. Formula for the volume of a circular cylinder can be written using the formula for the area of the circle, V equals BH. Or area of base circle equals pi radius squared, V equals pi radius squared height. So, volume of cylinder. Find the volume of a can that has radius of 4 centimeters and a height of 10 centimeters. Okay, there we go. Use the volume formula for circular cylinders. Okay, there's our formula. Fill in the numbers you know, multiply. Okay, that's how we do it. And then we get the volume of the can is about 502.4 cubic centimeters. Alright, cones. A cone has 1/3 the volume of a cylinder with the same size base. The formula for the volume of a circular cone is V equals 1/3 pi radius squared times height. Volume of a cone. The ice cream cone has a radius of 3 centimeters and a height of 14 centimeters. What is the volume of the ice cream cone? Here we go. There's our cone, so use the volume formula for circular cones. There's a formula. Okay, fill in the numbers you know. Okay, reduce. And then multiply. And that's what we get. So, the volume of the cone is about 132 cubic centimeters. You might see an equal sign with a dot over it instead of an equal sign with squiggly lines, and that means nearly equal to. Okay, and I think that's it. For further reading, read those books. There's the internet addresses, index. Have a nice day.